a god of mischief, and nobody really knew what he was going to do in Asgard. So we feel like Venus is kind of the Loki of our solar system. It's very mysterious. We don't know what's going on the surface. And the reason these mysteries are so intriguing is because Venus could be believed to be Earth gone wrong. And so if we find out more about what happened to Venus, we might be able to figure out what to do to stop it from happening to Earth, maybe. Some background information on Venus. Venus's surface is made up of 90% salt, and 65% of the planet's surface consists of volcanic lava plains. And from these facts, we know that volcanoes have played a major role in shaping Venus's surface. Because of the lack of high surface winds or rain, volcanoes can appear freshly formed for a very, very long time. Adds to the confusion of Venus. The Western Isla Regio is a large dome about 1.5 kilometers high and 2,000 kilometers wide. It has one of the most commonly known volcanoes, Sif Mons. It's the only picture we have of Venus. It's computer generated, but it's pretty cool. The number of craters on Venus is about the same as the number of craters on Earth, which is incredibly strange considering that Earth doesn't have many craters based on the tectonic plates and the weathering that occurs kind of removes the craters from the surface. There are more volcanoes on Venus than there are craters. There are 1,000 craters on Venus' surface and 1,600 major volcanoes. The amount of craters on Venus' surface suggests an age of 500 million years old. A day on Venus is longer than a year. A day on Venus is 443.7 Earth days long, while a year only lasts 442 days, Earth days. The surface is hot enough to melt lead. It's about 470 degrees Celsius. Past missions to Venus, the longest one to survive on Venus' surface only lasted about 2 hours before all the systems malfunctioned. So that's a problem. It has been tracked in the sky with the earliest evidence of this dating back to about 1,600 BC. Very old. Venus has a radius of 3,760 miles and a surface temperature of 27 degrees Celsius. The youngest volcano on Venus is located at Dynamo Regio, and that is where we plan to land our lander.
So here's our science question. Volcanoes have liquid water on its surface. We know that there can't be water on the Venusian surface now, but we found water molecules in the Venusian atmosphere. So maybe the water once came from the surface of the planet. My roommates will talk about how to prove this theory. If water actually once came from the surface, something must have happened to Venus to remove the water into the atmosphere. There are two theories about that. The first theory is about global warming. In this theory, there are oceans on the surface of Venus, just like Earth. But global warming happened on Venus. The planet got hotter and hotter, and the water evaporated. Some water photo-dissociated, some water vapor was blown into the outer space. A small part of water still remains in the atmosphere. Some scientists like this theory and think maybe Earth will become the second Venus. But the theory we prefer is the second theory that crystal receding events once brought the water from the surface of the planet into the atmosphere. There's more evidence about it because, as it says in the background information, there are only a few craters on Venus, so we can know that the surface is very young, which is a strong evidence that crystal receding progress was happened on Venus. And there are many volcanoes on Venus which play an important role in shaping the surface. So you will talk more about this theory.
So we have two mission objectives. Our first mission objective is to observe the composition of volcanic rocks near young volcanoes and see if they have rocks in them. So on Earth, there are gases that are are able to get samples and see if there's water in it. And the second mission objective is measure how much water vapor is in the atmosphere while also analyzing the basic composition of the atmosphere.
Now I'd like to explain the mission architecture, which is how the lander itself is going to work, and yeah, how it's constructed. So as I said, we will be using a lander for our mission. The lander will test the surface of Venus near Dione Reggio, as Linus said, for rocks with compositions that can lead to potential evidence for surface water on Venus in the past. Yeah. The lander will need a detachable heat shield, retro rockets, and disposable parachutes for the entry, descent, and landing, much like other missions which send landers and rovers to other planets. Like the other teams before us, we will use a radioisotope thermoelectric generator for sustainable energy. This is currently the best source of energy that exists, and since we are landing on Venus, we do not have to worry about planetary protection, which is protecting the possibility of life and the environment on the planet. Yeah. The lander will also be made of heat-resistant and acid-resistant materials such as carbon steel and titanium, besides other materials, which I'm not going to explain right now. Industrial-grade coolant will be there, as well as radiation hardening. Yeah, and they're both going to protect the circuitry inside the instruments that that helps us analyze the data from radiation and stuff. Yeah, we have 4 instruments. The first one is a quadrupole mass spectrometer, which separates the various isotopes in the rocks and in the atmosphere. Basically, what this does is it sends the ions from vaporized materials into an electric field and differentiates between them by looking at how much their trajectories wobble in either way. Yeah. We will also have a tunable laser spectrometer, which was on the MSL, the Mars Science Laboratory, to melt rocks into plasma and analyzes their compositions. We're gonna melt rocks, then look at how they glow. We will also have a gas chromatograph, which separates the different materials within our samples. In this, we inject gas into a chamber, and we see how the gas hits the walls of the chamber and connects with it. We'll also have a camera. This is the final instrument. The camera called the MassCam, which was also on the MSL, the Mars Science Laboratory. And we will use this to take pictures of the surface for a more visual understanding of what the golden planet is like. Yeah, that's probably it. Thank you. Thank you.
Questions?
So if past missions only lasted about 2 hours, what's your mission now last?
So the Venera landers, the Venera landers were by the Russians, and those lasted for a very short time because of the technological and economical limits that the Russians were under. We're going to be able to use up to $1 billion, and we've developed much better materials that can exist under heavy pressure and acid. And so we think that this mission will last at least a week. If possible, we'd like it to last for a few months. Yeah, that's the time scale we have to talk about on Venus.
Any other questions? Yeah.
Yeah. Are there actual materials, really materials that could last
Yeah.
with that heat and pressure?
Give examples of some of the materials that would
Are
help
these
to stop the
man-made?
heat. Yeah.
Oh, these are man-made materials?
There's carbon steel, which can exist under sulfuric acid. There is titanium, which is a really popular and resistant material to force. And we also have materials such as beryllium, copper, and other materials that are used in modern guns, which can withstand large amounts of pressure. Yeah.
Well, it's just a question I asked before, how long is your mission successful? How long does it last? I mean, you didn't answer that question.
It will last for about a week.
A week, okay.
Well, are you asking how long does it have to be successful?
Well, we know that the past mission lasts 2 hours. You're saying you're using other materials that are higher strength. What are you planning your mission to last
A week.
for? A week?
Well, yeah, at longest.
We want it to be a week because we want to be able to get a sufficient amount of samples from the surface of Venus. But to just get, for our mission to be successful, we just want samples from the atmosphere and from the surface. We want to be able to know the composition